We need to find the probability that a student plans to attend college after high school if the student is a girl. We're going to rewrite the table using symbols for the different entries. Going to college will be C, capital C. Boys will be B, capital B. And girls are going to be capital G. Now, we'll just leave yes as yes and no as no. Let's see what we have here. 342, those are the boys going to college. 376, the girls going to college. 151, boys not going to college. And 138, girls not going to college. Now we're going to total them, add them up. The number of boys in total is 493. The number of girls in total is 514. The total number of students is 1,007. The total number of students going to college is 718. The total number of students not going to college is 289. Now we see that by adding an extra column and an extra row, we get more info about the data. So the total number of students is 1,007. Now the probability that a student attend college, so it's C, given that the student is a girl. G will be the total number of girls, which is 514. And that total should be our denominator. Now, the number of girl going to college is 376. So is the number of girls going to college over the total number of girls. And that probability is 73.2. Now let's explain what happened here. We are dealing with two probabilities. First, the probability that the student attending is a girl, which is 5, the total number of girls, 514 over 1,007. And then the probability of being a girl and going to college. So it's the probability of meeting a girl that's going to college is 376 over 1,007. Now the probability of, now given the student is a girl, the probability that the student plans to attend college will be 376 over 1,007 divided by 514 over 1,007. Now 1,007 will cancel out. That's the reason why we do not have to write it out this way. So we'll get the same answer. In conclusion, we're going to say that the probability of C given G is equal to the probability of C and G, probability of getting both, divided by the probability of G, the probability of the denominator. And this is called a conditional probability. The probability of B occurs given that A occurs is called a conditional probability. It is read P of B given A. We're going to determine the probability of F, which is the probability that we roll a 5. There's only one 5, so it's going to be P of F will be equal to 1 over 6. We have 6 events in the sample space, approximately 16.7%. P of F given O. So given that the number is odd, what's the probability of getting a 5? There are 1, 2, 3 odd numbers. And out of those three odd numbers, there's only one 5. So it's 1/3, which is 33.3%. The probability that the number is odd, given that the number is not 5. If the number is not 5, we have about 6 numbers. So without the 5, it'll be 5 numbers left. If the number is not 5, we have 5 numbers left. And if 5 is not taken into consideration, we only have 2 odd numbers. So that probability is 2 out of 5, which is 40%. The probability of getting a king. We have 4 kings and a total of 52 cards. So the probability of getting a king is 4 over 52. When divided by 4 is 1 over 13, which is approximately 7.69%. B, the probability of getting B given A. Probability of getting a king given a face card. How many face cards do we have? Well, we have 12 face cards. How many kings do we have in those 12 face cards? 4 kings. So it's 4 over 12, which is 1 over 3, 1/3, 33.3%. Given that the event is a heart, what's the probability of getting a king? We have 13 hearts, and out of those 13, we only have 1 king. So it's 1 over 13, which is 7.69, approximately 7.69%. We are looking at the probability of selecting a king if the card is not a face card. Not a face card means we're gonna have to take all 12 of them out of those 52 cards. Therefore, it's going to be 52 minus 12, which is 40. Now that out of those 40, the probability of getting a king is 0 because we eliminated all the face cards, so 0%. E, the probability of selecting a face card. How many face cards do we have? 12 of them. How many cards in total? 52. So the probability of a face card is 12 over 52, which is 3 over 13, or 23.1%. The probability of getting a face card, given that the card is a king, well, we have 4 kings, and all 4 are face cards. So it's 4 over 4, which is 1 or 100%. The probability of getting a face card if a heart is selected. We have 13 heart, and out of those 13, we have 3 face cards: Jack, the Queen, and the King. 23.1%. The probability of getting a face card, given that the card is not a king. We subtract the number of king from 52, we get 48 cards. Well, without the 4 kings, the number of face cards are 8. 8 face cards. Therefore, it's 8 over 48, which when divided by 8 is 1 over 6, or 16.67%.